Okay, the last presenter of this session is Philippe de Groote, and the title is Deriving Formal Semantic Representation from Dependency Structures.
Okay. So the goal of this talk is to pave the way for a sort of Montegovian interpretation of dependencies. And as an introduction, I would like to start with an example of Montague semantics. So the focus is not excellent. I do not know whether you can read it, but so this is the syntactic tree of sentence. Michael drives a red car. That's going to be my running example. And in Montague semantics, what it does is to assign semantic recipes to the lexical items, and then from the semantic recipes, one computes the semantics of the constituent. So, for instance, from the semantic recipes of red and the semantic recipe of car, one compute the meaning of red car, and so on and so forth. A red car, the verb phrase drive a red car, and finally we obtain the semantic representation of the complete sentence. And of course, this process is completely based on the notion of constituent. And the problem is that in a dependency structure, so for the same sentence, we would obtain a structure like this. This is exactly what you would obtain with the Stanford parser, actually. And the notion of constituent is no longer applied. Of course, you may use some extra knowledge to try to retrieve that notion and say, okay, red car, that's a constituent. A red car, that's the object, that's another constituent. Drive a red car, that's a verb phrase. And then finally, we obtain the sentence. But this information is not in the dependency structure. And actually, we do not want to use such external information. And from the dependency structure, you might guess that Michael drives is a constituent, which is not the case. Okay, and in fact, the reason we do not want to just somehow retrieve the parse tree from the dependency structure and then apply the usual process is because it is not clear that we can always retrieve that constituent structure, that parse tree, and especially in the case where the dependency structure would be partial, which is one of the advantages of dependency parsing. For ungrammatical sentences or incomplete sentences, it already gives some dependencies. And from those dependencies, you may guess a part of the meaning. Okay, so the outline of my talk, the goal, therefore, is to derive, as I said, Montague-like semantics for dependency structures, but in a robust way, in the sense that it would apply to partial structures, allowing a treatment of quantification, which I have not seen in other approaches to a Montague-like semantics for dependency structures. As I said, without relying on the notion of constituent, and taking seriously the dependency, okay, and trying to give somehow a meaning to those dependencies. Okay, and what I will do in this talk is to present a very simple basic idea, which is present in other papers actually and in related work. And then I will state a very simple coherence requirement. And from that requirement, I will derive possible interpretation up to giving a meaning to my running as an example. And then I will end with examples about partial dependency structures and scope ambiguities. Okay, so the idea, the simple idea is the following. If we consider that the dependency is after all a relation between two things, well, there is a way of presenting such a relation that is a function that takes two arguments and that would give a truth value. Okay, and so syntactically, it would mean that that dependency structure would be represented by a term like this, a function and such, applied to the two arguments of the dependency. And then, if we stick to the meaning, given in a sort of standard Montague semantics of verb phrase and noun phrases, okay, which would be like this. So noun phrases being like type-raised entities, and verb phrases being like predicates. Then and such should just assemble those two recipes, and in this case it's quite easy. It's really as in Montague, you would give the verb phrases an argument to the noun phrase. Okay, but of course it's not that simple. As soon as you have more than one dependency, of course, if you do not want to take that sort of extra information of where are the constituents, then you have the fact that there are two ways of writing your structure using that basic idea. And then we want the meaning to be independent of the way we are representing the structure. So the coherence requirement is that the two computations should yield the same value. And a way of doing this, and which is also interesting for partial interpretation of partial structures, is to rely to event semantics. And so by relying on event semantics, usually or initially it was presented as the interpretation of a sentence is a set of events. But it is known that this way of doing things is not very compatible with quantification, because you have the problem that the existential closure on the events should take the narrowest scope. And so a way out of this has been proposed by Champollion. It consists of interpreting a sentence as a set of events. Okay, and so the way the verb would be represented as a set of events. Is function for you. It's completely standard. I'm trying to be as standard as possible in the meaning of the lexical items. And so a way of saying that is that the existential closure is already present, okay? And then you have a sort of continuation in the form of a conjunction, and you may add information about the event with that argument on that P. And then my two dependencies, there might be a little bit involved to read, but what they say is that they're going to take a verb and something like a noun or like a noun phrase, and then well, that noun phrase gonna be applied to the verb as in Montague, but the verb will receive the information that the entity corresponding to the noun phrase is the agent of the event. And in the case of the object, that it is the theme of the event. And then there is that lambda p here, which is just the fact that we want to have a general sentence at the end, and from an operational point of view, the fact that we should continue to be able to add information about the event. Okay. And now let's look at the noun phrases. Okay, a red card. So even though we do not have a notion of constituent, what we have at least is that notion of a head, and with all the things that are dependent on that head. Okay, like in here, a red card. And again, I should apply my coherence requirement to this. Okay, and in fact, in general, when you have more than one dependency, like in here, okay, if you say, okay, let's say that the type of the first dependency is alpha 1 arrow, beta 1 arrow, gamma 1. Alpha 2, beta 2, gamma 2 for the second dependency. Because of the coherence requirement, the only solution is to have that alpha 1 and alpha 2 are the same, and that gamma 1 and gamma 2 are the same. And so, in general, dependencies should always have as first argument and as result something of the same type. So, in this case, because of that requirement, the coherence requirement, it means that all those expressions could have the same type, which is not usual. Okay, usually when we say that maybe a red car is the same type as a car, but that as soon as you have a determinant, then it's no longer the same type. Okay, and actually there are people in the world of dependency grammar that are arguing for the fact that they want the determiner to be the head of such a group, but it's not what is done usually. So I'm sticking to what is done usually. And so the solution I propose is like this. Okay, As usual, I will consider that a noun is an interpretation, a set of entities, that an adjective, that a determiner allow a noun phrase to be made of a noun. And then to all those expressions, car, red car, a car, I will give a generalized type, which will be like that. Something waiting for determiner and an adjective and or a modifier and giving a noun phrase. Okay, and then the determiner and the adjective as the usual meaning, and car, which should be of that type, well, it takes two arguments, the determiners, the modifiers, and then the modifiers is applied to the name car, and the name itself is applied to the possible determiners. And then I will not explain this in detail, but because we want to obtain the set type at the end, even though we are giving a determiner to the noun, we are still waiting for determiner. That would be that lambda c here. But that lambda c is a dummy variable. It does not appear. On the other hand, for the modification, the new modifier, lambda b, still appear because you may have more than one adjective or more than one adjunction for your noun. Okay, and now since I have changed the type of the noun phrase, well, I should revisit my dependencies for object and subject. Okay, and well, the recipes attached to the lexical items, we already know what they must be. And this is just these two ones that we should revisit in order to have them taking, actually it should be G and E here, generalized and P. And well, I will not detail the lambda term, trust me, or look at them in the pre-proceedings. But what is interesting is that when this relation takes a generalized non-phrasal subject, then it provides the arguments, determiner and modifier to the subject. And the modifier is just the identity. So it ends the fact that the noun may receive an adjunct. And the determiner, here I just give some. It's an arbitrary determiner. In case the structure would be broken, then we would have an existential. But you may think of something even weaker in terms of default determiner. And then with these recipes, in fact, I obtained what one would expect in event semantics. Okay, that there exists a car which is red, and that there exists a driving event, and that M, the entity M, is the agent of that driving event, and that the car X is the theme of that driving event. And then it's like in Bourgeois Gentilhomme, Belle Marquise, all the other way of representing the structure will give you the same interpretation, up to commutativity of conjunction, of course. And then, well, as a matter of fact, if I have like a partial structure like this one, well, I obtain that there is a red car, and that that red car is a key a driving event, and that's it. But that's exactly what I would obtain. And the existential here, because it was my default quantifier, but if we would have put another one, the possible existence of a car or something like that, that's what we would get. And then, interestingly enough, if I have quantifiers, in fact, the coherence requirement then is broken, but it just corresponds to the two readings we spoke on. So I will stop here because of the clock.
Okay, thank you very much. Okay, we have about 10 minutes for discussion.
Thank you. So this is very interesting. But I was wondering if you have thought about how to generalize this to cover other operators in natural language, like modal auxiliaries, raising control verbs, and coordination.
Okay, these are really like laying the principle of an approach that we want to generalize. Yeah, clearly there are a lot of constructions that are under the agenda, but the point is that well, in my group I have people who are working with dependencies, and they have big corpora full of annotations in several languages, including languages that they do not understand. So it's part of the Joachim Neve Universal Dependency Project. And so what we want to do is to stick to those annotations. And in some cases, like examples like this, it works, okay? For conjunction, typically, I'm not sure that it will work, because conjunction, the way that they are annotating conjunction is really terrible. Okay, it's really terrible. There is one stake of, I don't know, John, Jean, and Mary. There is one which is the head, and then there are links from the head to the other nerve. So for conjunction, but even if you even just for parsing and to having like deep structure from the dependency structure, what they call enhanced dependencies, even for that, they have problem themselves with conjunction. But for other constructions, maybe not all of them, we are confident that something going to be possible.
I think my question was how to get.
Oh, I may add something. The fact that there are also discussion about those dependency grammarian, whether they made a good choice, it's etc. And so if we are running in very complicated semantic problems, that might be a clue that we may give them, that maybe their choice was not the good one. And conjunctions is definitely an example.
Well, I have one general question and one
Yeah.
specific question. The first general question is that how this operation is typeface. In other words, how these levels in the dependency tree are consistent. So your system always be able to convert the dependency tree into a consistent semantic composition.
At least to obtain the structure
Yeah.
with the relation, etc., up to some arbitrary order.
Yeah.
Yeah, that's
My
the way-
question is like, in the subject is always, modifying NNP. But that, is there any case where any subject modifies other things than that?
Okay. Yeah, that's an interesting question. There are some dependencies clearly that will give that's going to be ambiguous in the sense that we will need different types for them. Certainly, that's under investigation. What should be noticed in that context is that NNP, VBZ, etc., are not really syntactic categories. They are just the tags that the tagger is giving. Okay, but that's what we have as types at the moment.
Okay, another specific question is that how this system deals with the bridge movement. How the extractions are encoded in the dependency tree, and can you actually translate these things well?
Yeah. I'm not sure enough of the way typically relative or questions, etc., or they are annotating it. Okay, I know that in the case of relative, for instance, when they transform the dependency structure into a deeper structure, they find possibly the subject, the actual subject of the relative clause. Okay, so this means that they are able to find the extraction. I look a little bit at the WH question, and for that, yeah, I think that extraction will be really problematic.
Okay, thank you very much.
I'm more of a comments than a question, but also a question. It's kind of a little bit, I mean, as I understand the overall game, so we have the graph representing dependent structure, right? And we want to map it to mean, and we want to be compositional, right? Because we said Montague. So we want to find a homomorphism from a graph to some kind of representation that's meaningful representation, right? And so it's okay. So I mean, that's all we do, but it seems to be you're committed to some particular research homomorphism among particular restricted subset. And then, I mean, I don't understand why you, made this particular commitment. For example, I know you say n subject, you decided to represent the graph like, here this, object needs somebody, and then n subject apply to an object. But there's a different way to represent it. For example, object applies something and subject applies to something, and then there is a combining terms that takes them and combines, right? For example, in here you have, arc goes object, right?
Yes,
so
yes.
It means would be object needs somebody, and would be another term has subject needs everybody, and would be another term says, all of them are conjunction. Sub needs somebody, needs everybody. So you introduce, so different way of representing the same graph, right? In that case, if this, the combining relationship is commutative, then coherence automatically satisfied, and you don't need to have any type constraint, right? Which, in a sense, what you do with event semantics by introducing this add, that you kind of get something like that. Although when you get to noun phrases, you don't use the same trick. So use the, more complicated treatment for NP phrases. where you, I mean, which is different from the traces, from the trick that you use for VP phrases. It's kind of seems to be, I mean, I don't know, well, not, I don't want to say inconsistent, but it's kind of, I mean, from the point of view of minimal, try to, I mean, find a minimal treatment, a kind of, I mean, I don't know, it kind of seems to be using the same principle everywhere, seems to be kind of, well, appealing. Not that it's wrong, I mean, doing otherwise, but it's just purely aesthetical and more appealing. So what do you think about it?
Yeah, the fact that the treatment for verb phrases and non-phrases are different, and the fact that technically it would be possible to have something similar, something we thought about, but the choice is more like a methodological choice, which is to try to stick to what people may recognize. Okay, like what an event is, how quantification is used in Montague grammar. There is something a little bit similar made by Mark Steedman and co-authors, where in fact he also uses the dependencies as functions with two arguments, but then all the arguments are of type set of pair of events entities. So they are all V cross E arrow T, and then he also they also have like a canonical order in the way of evaluating this thing, but I do not know, and I have not seen any treatment of quantification with that thing.
Okay, so it's kind of, yeah, it was, my question was kind of methodology. So because there is choice and why you, I mean, chose particular way for going through the search space. So.
Okay, so now the time is up. So if you have any other question, please write a comment on the chat or send an email to Philippe. Thank you very much again.